in the deserts of Gansu province. Behind a veil of sand and silence, China just did something no other country has managed to accomplish in nearly a century of nuclear research. They lit up the world's first operational thorium molten salt nuclear reactor, a technology first imagined in the laboratories of America during World War II. It's not just a scientific milestone. It's a geopolitical pivot, a reshuffling of the energy order, and potentially the beginning of a new nuclear era. China has taken an experimental footnote from U.S. history and transformed it into a working machine. Before we go deeper, if you're even a little impressed by the idea of melting rocks into clean energy that could power the next century, hit that like button. It helps this kind of content reach more curious minds like yours. Back in the 1940s, American scientists at Oak Ridge were already working with thorium. The problem was never that it didn't work. It was that it didn't produce weapons-grade byproducts. Uranium and plutonium did, and the Cold War made the choice for them. The U.S. had military priorities, not energy independence. So thorium was shelved. That strategic fork in the road shaped 80 years of nuclear policy. But China doesn't have the same priorities, nor the same constraints. What makes thorium special isn't just that it's 3 times more abundant than uranium. It's that it burns cleaner. It can't melt down like traditional reactors and produces far less long-term waste. Imagine an energy source that doesn't threaten catastrophe if the cooling system fails. That's thorium. But what makes China's reactor especially groundbreaking is that it's based on a molten salt design, which means the fuel is dissolved in liquid, eliminating the risk of nuclear meltdown altogether. This isn't science fiction anymore. It's an engineering fact. China's prototype, officially known as the TMSR LF1, isn't a theory. It's real. It's running. And if it works the way they expect, it will lead to full-scale reactors powering millions within a decade. This is the energy equivalent of moving from the telegraph to the smartphone, skipping a century of incremental development, and leaping ahead into something fundamentally different. The reactor's location is strategic too. Gansu is remote, dry, and ideal for testing and isolation, but it's also symbolic. It sends a clear message to the world. China isn't just copying Western technology anymore, it's surpassing it. While the U.S. remains locked in regulatory red tape and public fear of nuclear energy, China is experimenting, building, and now operationalizing ideas long thought abandoned. And here's the kicker. This thorium reactor has no need for water cooling. That means it can operate in deserts, in remote military zones, or even potentially in space. It's a power source for environments where traditional energy just can't survive. If that doesn't grab your attention, it should, because it rewrites the rules of what's possible when it comes to decentralizing energy production. It might shock you to know that the very first thorium reactor wasn't built by China. It was built in Tennessee at the Oak Ridge National Laboratory in the 1960s. Dr. Alvin Weinberg, a pioneer of nuclear innovation, believed thorium could be the key to unlimited clean energy. And for a while, it looked like America might lead this revolution. But history took a darker turn. The U.S. government wasn't looking for a peaceful energy source. It wanted bombs. And thorium couldn't deliver that. Uranium and plutonium could. That's why the molten salt reactor program was shut down by the early 70s. Not because it failed, but because it succeeded in a way the military-industrial complex didn't find useful. That single decision may have cost the U.S. half a century of nuclear progress. Fast forward to the day, and the tables have turned. China now leads the world in thorium reactor research, having invested over $500 million into its development. Their program isn't just about a single test reactor. It's about building a blueprint for a fleet of reactors that could redefine the country's energy landscape and export that model worldwide. Energy domination through innovation, not invasion. Why thorium, though? Because it solves problems that uranium reactors can't. Its byproducts are less toxic. Its operation is inherently safer. It's harder to weaponize. And most importantly, it allows China to use a fuel source it already has in abundance. In fact, China's rare earth mining industry produces thorium as a byproduct. So instead of throwing it away, they're now turning it into energy. America had the first draft, but China is writing the final chapter. And that chapter might just end with the world powering its homes and factories on a fuel source once dismissed as too peaceful. Let that sink in. Peaceful energy was once seen as a disadvantage. The silence from the West is deafening. Where once there was scientific ambition, there's now paralysis. China's thorium program isn't perfect. It's still in early stages. But the U.S. doesn't even have one. That speaks volumes. When you stop funding future tech because of past politics, this is what happens. You get leapfrogged. What's most striking is how thorium sidesteps the very design flaws that have haunted nuclear power for decades. Traditional reactors operate under extreme pressure, meaning any breach can result in catastrophic failure. Thorium molten salt reactors flip that model. They run at atmospheric pressure, dramatically reducing the risk of explosions or radiation leaks. It's not just safer, it's structurally simpler and cheaper to build. This design elegance also means modular scalability. Unlike massive uranium plants that take years and billions to construct, thorium reactors can be built smaller, faster, and in clusters. That opens the door to decentralized grids, rural electrification, disaster-resilient systems, even portable power units for off-grid regions. It's not just a new kind of reactor. It's a new blueprint for how energy is delivered, and the benefits scale with adoption. Once a nation develops the supply chain to fabricate thorium salt, container systems, and heat exchangers, each additional unit becomes cheaper. That's how solar grew. That's how batteries evolved. And that's how thorium could move from experimental to exponential. The cost curve bends down, while safety and efficiency bend up. More importantly, it resets public trust in nuclear energy. Fear of radiation, meltdown, and waste has kept nuclear power in political limbo for decades. But a reactor that self-regulates, can't explode, and generates waste safe in 300 years? That's a narrative the public can understand, and maybe even embrace. Education and perception shift faster when design eliminates the scary parts. And once perception shifts, policy follows. Politicians don't lead energy revolutions. They follow voter sentiment and industry lobbying. If enough people see thorium as clean, modern, and safe, it forces a legislative pivot. Permitting gets easier. Incentives get unlocked. And suddenly, what seemed fringe became mainstream. If this shift surprises you, drop a comment. Would you trust a reactor that doesn't melt down? Or does it still sound like science fiction to you? The core of China's new reactor is radically different from what most people picture when they think of nuclear power. There are no solid rods, no pressurized water tanks, no steam explosions waiting to happen. Instead, thorium is dissolved into a molten fluoride salt that circulates in a loop. This liquid both fuels and cools the reactor. It's elegant, compact, and, most importantly, safe by design. If the reactor overheats, the salt expands, slowing the nuclear reactions naturally. If something goes wrong, a freeze plug at the bottom melts, and the molten fuel drains into a containment tank. That's it. No need for human intervention. No risk of a Fukushima-style meltdown. This isn't fail-safe. It's failure-friendly. That alone is revolutionary. But the brilliance doesn't stop there. Thorium itself is fertile, not fissile. That means it needs a kickstart from another material like uranium-233 to begin the reaction. Once started, it breeds its own fissile material and sustains the chain. This makes it incredibly hard to weaponize, which is exactly why it was rejected during the Cold War, and exactly why it's perfect now. Molten salt reactors also operate at higher temperatures, but lower pressures than conventional ones. That means more efficient heat exchange, better energy conversion, and smaller, cheaper infrastructure. In other words, more power for less risk and lower cost. It's like upgrading from a coal-burning furnace to a smart induction stove. More heat, less hazard. There's another overlooked benefit: waste. Conventional reactors produce radioactive leftovers that can remain dangerous for tens of thousands of years. Thorium's waste? Mostly safe within 300 years. That may still sound like a long time, but in nuclear terms, it's a blink. Generations can manage that. Civilizations can't handle the other kind. And yet, Western media has been strangely quiet about this breakthrough. That silence is telling. Maybe because acknowledging China's leap forward also means admitting our own stagnation. But progress doesn't wait for permission, and China isn't waiting for anyone. If you are this far, make sure you're subscribed. We break down the breakthroughs others gloss over. And trust me, this thorium story is just heating up. Energy isn't just about electricity. It's about leverage. And by launching the world's first operational thorium reactor, China has quietly shifted the balance of future power, both literally and diplomatically. The nations that control clean, scalable energy will dominate the 21st century. That's not speculation. That's the roadmap. While the U.S. is busy debating gas stoves and solar subsidies, China is building a scalable reactor that could decouple entire regions from fossil fuels. And when you control the infrastructure for clean energy, you don't just sell electricity. You sell independence from oil cartels, from Russian pipelines, from climate treaties. That's hard power dressed in a lab coat. It's not just about domestic energy. China has its eyes on export markets. Imagine smaller, portable thorium reactors shipped to developing nations: Africa, Southeast Asia, South America. Clean energy diplomacy. Influence without occupation. Partnerships built not on debt, but on kilowatts. It's the Belt and Road Initiative version 2.0. Meanwhile, Western nuclear programs are bogged down by cost overruns, lawsuits, and NIMBY resistance. Thorium isn't even part of the conversation in Washington, and that's the real danger. When innovation moves faster than regulation, the countries that move first get to write the rules. Everyone else just follows them. Even India, which also has vast thorium reserves, has made slower progress despite early interest. China now leads the pack, not just in prototypes, but in actual implementation. The technology gap is widening, and this time it's not about microchips or TikTok. It's about megawatts. And if you think energy doesn't affect global politics, look no further than every war in the past 70 years. Control the fuel, and you control the fight. China just built a new kind of fuel, and they didn't need to fire a shot. Drop a like if you believe the world should pay more attention to energy breakthroughs like this. It might just be the story that shapes your kid's future. Part of what makes this story so fascinating is that thorium's advantages were never secret. They were just inconvenient. For decades, it sat on the shelf, too clean for war, too different for big nuclear contracts, and too futuristic for short-term politics. But China plays a long game. Western nations were shackled by legacy systems. Entire supply chains were built around uranium. Utilities were trained on one model. Regulators were slow to adapt. And investors didn't want to fund something that couldn't be patented or monopolized easily. Thorium was too open source for capitalist incentives and too peaceful for military ones. Even environmentalists got it wrong. They lumped all nuclear energy together, fearing another Chernobyl while ignoring designs that couldn't even melt down. That stigma kept thorium buried under layers of misunderstanding, bureaucracy, and fear. Until now, China didn't just revive the idea. They rebuilt it from the reactor vessel up. And in doing so, they've created a pathway for a new kind of global energy mix. One that doesn't require constant mining, doesn't threaten cities, and doesn't leave behind waste for eternity. The timing is perfect. The world needs clean baseload energy to stabilize the volatility of wind and solar. Batteries are improving, but they're not enough. And fossil fuels, while reliable, are no longer sustainable. Thorium hits the sweet spot, and China just proved it. So, why aren't we talking about it more? That's the question. Maybe it's time we did. Maybe it's time to question why innovation so often dies in the shadow of outdated priorities. Because thorium challenges more than just technology. It challenges power structures. When a nation like China develops a clean, safe, and potentially decentralized energy source, it doesn't just shift the science. It shifts the geopolitical game board. Countries that once held energy leverage through oil or uranium-based nuclear deals may suddenly find themselves irrelevant. That's a threat to more than just the fossil fuel industry. It's a threat to entire international alliances built on energy dependence. And let's be clear, this wasn't accidental. China's thorium reactor didn't emerge from a stark garage. It came from deep coordination between scientific institutions, government funding, and national security priorities. It was methodical. They weren't gambling on a trend. They were investing in strategic independence. The reactor is just a visible part of the iceberg. What lies beneath is a whole ecosystem being engineered to scale. That's what makes it different from the piecemeal efforts in the West. In the U.S., thorium was always a what if. In China, it's a when, not an if. And that shift in certainty is more important than the technology itself. Once something is certain, capital flows, policy adjusts, infrastructure follows. The future, in other words, gets permission to arrive. If that permission spreads globally, the implications could be massive. Countries without uranium supplies, nations left out of the traditional nuclear club, might leapfrog into energy security by following China's model. That changes not only domestic policy, but foreign policy. Energy deals would no longer be just pipelines and ports. They'd be blueprints and molten salt expertise. The balance of power tilts toward those who control design, not just raw material. And that's the real trigger here. Because once thorium becomes scalable and exportable, it becomes an instrument of soft power. Quiet, nonviolent, but deeply influential. Just like Huawei did with 5G, China could position itself as the global vendor for next-generation energy infrastructure. Leave a comment below. Should the U.S. resurrect its thorium program? Or is this China's energy century now? This isn't a science project. It's an industrial strategy at national scale. China's move to operationalize thorium signals more than innovation. It signals control over an entire alternative energy paradigm. The fuel cycle, reactor design, waste management, all of it is being vertically integrated. That means they won't just sell reactors. They'll sell the system, the training, the standards. They're not chasing clean energy headlines. They're laying down the architecture for energy dominance in the 21st century. What's quietly brilliant is how thorium avoids the very bottlenecks that have plagued uranium. Mining intensity, proliferation risks, weapons-grade byproducts. Thorium's natural resistance to weaponization turns it into a diplomatic tool. Nations that adopt it won't be inviting IAEA inspections for warheads. They'll be installing zero-pressure reactors in remote regions. That creates energy independence without triggering arms races. It's nuclear without the baggage. And while the West debates regulatory frameworks, China is manufacturing expertise. They're producing not just the tech, but the talent to run it. Engineers, operators, maintenance teams, all trained in a new doctrine. This is how standards are set before treaties are even discussed. If the rest of the world wants to catch up, they won't just need thorium. They'll need Chinese instruction manuals. That's the new leverage. Once thorium power plants begin appearing in Africa, Southeast Asia, or South America, the global energy supply map will start to look very different. Not centralized around oil fields or gas terminals, but distributed across modular, safe nuclear units. And if China provides the first 10 units under favorable financing or partnerships, you just witness the beginning of the Belt and Reactors era, a new phase in their global infrastructure push. And yet, the West still holds one advantage: trust. For all of China's progress, questions remain about transparency, environmental oversight, and long-term reliability. That's the opening. If the U.S. or EU were to pivot quickly, adopt thorium on their own terms, and lead with governance and safety, the playing field could rebalance. But that window won't stay open forever. This moment isn't about a single reactor humming quietly in a desert lab. It's about what comes next. China has plans to scale this into full commercial models by 2030. If successful, this will mark the beginning of the end for uranium-dominated nuclear energy. Not because uranium failed, but because something better finally arrived. The real impact won't be immediate. It will ripple slowly through energy policy, scientific funding, international diplomacy. But make no mistake, the ripples will come. A nation willing to revive shelf science, to fund what others abandoned, and to build what others feared. That nation is betting on the long view. And that's a bet the world can't afford to ignore. This story isn't just about thorium. It's about lost time, rediscovered wisdom, and the courage to question old assumptions. Whether you trust China or not, the fact remains they acted, and now the rest of us are watching. The game has shifted. The rules are being rewritten. What happens next depends on who decides to follow, who dares to leap, and who continues to pretend the old ways still work. Because after today, they don't. Not in a world powered by liquid salt and radioactive rocks that refuse to melt down. It's not just that China built a thorium reactor, it's that they changed the tempo. They didn't wait for consensus or permission. They engineered the future while the rest of the world was still arguing over the past. That kind of initiative doesn't just make headlines, it makes history. And for once, history isn't being written in Washington or Brussels. It's being engineered in Lanzhou. We are witnessing a pivot point in energy, but also in mindset. The nations that recognize this moment will pivot with it. Those that don't will fall behind, not gradually, but exponentially, because the energy race isn't linear. It accelerates. And thorium isn't just a fuel, it's the ignition switch. If you think this was just a Chinese breakthrough, you're missing the point. This is a global signal. The technology is real. The momentum is real. What's missing is leadership from the rest of the world. Thorium reactors won't stay a Chinese monopoly forever, but they will be remembered as a Chinese initiative unless others act now. So here's the final takeaway. Energy defines empires. Coal powered the British Empire. Oil powered the American century. And thorium? It just might power whatever comes next. The only question left is, who's ready to plug into it? If this blew your mind, share it. Let someone else hear the energy story no one's telling. And don't forget, subscribe for more breakthrough breakdowns. This is the future. Let's not sleep through it.